Dawn opens slowly over the skeletal horizon of Pripyat. The light does not arrive gently here. It filters through shattered windows and stairwell voids, sliding across the concrete like a cautious intruder. Apartment towers rise from the forest like the ribs of some leviathan long dead, their balconies sagging, their paint long surrendered to frost and rain. At the edge of the square, the Ferris wheel stands frozen in perpetual anticipation, yellow gondolas suspended in rust, destined never to carry the laughter they were built for. Beneath it, grass pushes through the asphalt. Birch trees weave their roots through the cracks of the playground tiles. Nature does not mourn, it occupies. A radiation warning sign leans at an angle, its red symbol faded but unmistakable. Moss climbs its edges. Ivy coils around its metal post. The warning remains. The forest does not care. The wind moves through empty apartment blocks, humming in corridors that once echoed with footsteps and conversation. Doors hang ajar. Curtains sway in shattered frames. Somewhere in the distance, a faint mechanical rhythm breaks the silence. The steady, unsettling pulse of a Geiger counter. Click, click, click. Invisible particles drift through the air, silent and indifferent. Radiation has no smell. It has no shadow. It has no mercy. This land was declared uninhabitable, abandoned in haste, sealed by fear. And yet, movement. Among the concrete pillars of a collapsed warehouse, a shape materializes. A wolf steps forward, deliberate and unhurried. Its breath hangs in the cool morning air. Amber eyes survey the courtyard where children once played. The animal lowers its head, nostrils flaring, reading scents layered over decades, rust, moss, lingering ash, and something far older than reactors or cities, territory. On ash-colored ground beside a ruined bus stop, hoofprints press into the damp earth, fresh, deep. A herd has passed here in the night, silent as mist. The forest now keeps its own schedules. Above the dome of the Chernobyl nuclear plant's reactor, a crow takes flight into the sky. Its wings beat against the pale horizon, black against silver clouds. It circles once, twice, and then disappears toward the wetlands beyond the cooling towers, without hesitation, without fear. Silence returns, but it is no longer empty. Where humanity retreated, the wild advanced. Beneath the soil, roots spread unchecked. In abandoned kitchens, foxes make dens. On rooftops, storks build nests of branches and wire. The exclusion zone, 30 kilometers of imposed absence, has become something entirely different. It is not safe, it is not healed, but it is alive. Radiation persists in pockets of forest and field, embedded in bark and bone. It shapes life in ways still being measured, still being debated, and yet life persists, adapts, multiplies. The paradox is stark. In the shadow of one of humanity's greatest technological failures, ecosystems surge. The forest stretches to the horizon, swallowing roads, reclaiming railways, threading through the skeleton of a city that stands as monument and warning. The Geiger counter clicks again, but louder still is the brush of fur through tall grass, the snap of a twig beneath cautious paws, the beating of wings against the open sky. Welcome to Chernobyl, where catastrophe did not end life, it rewrote it. On the 26th of April 1986, reactor number 4 of the Chernobyl nuclear power plant ruptured in a surge of heat and flawed design. Graphite burned. A column of radioactive material rose into the night sky and drifted across borders, invisible and immense. Within hours, an accident became a continental event. In the days that followed, buses filled the streets of Pripyat. Families were told to pack lightly. They would return soon, they were assured. They never did. A 30-kilometer exclusion zone was drawn around the reactor, an improvised boundary between contamination and normality. Soldiers erected checkpoints. Farms were abandoned mid-season. Livestock was left behind. Schools closed their doors in the middle of the spring term. Then, abruptly, the machinery of everyday human life stopped. Fields once ploughed in straight lines began to blur at the edges. Wheat gave way to weeds, weeds to shrubs, shrubs to young forest. Without tractors to cut them back, saplings broke through cracked asphalt. Without chainsaws, the forest thickened. Without gunfire, animals listened differently. Inside an overgrown schoolyard, swings creak in the wind, grass floods the basketball court. In a classroom, where maps still hang crooked on the wall, a fox trots lightly between desks. Its paws stir dust, undisturbed for decades. It pauses, ears tilted forward, then slips through a shattered window and disappears into the yard. In what was once an orchard behind a village house, wild boars root through the soil. Their snouts churn earth where potatoes and cabbages once grew. Piglets dart between their mothers' legs, squealing softly. The fence that once kept animals out now serves only as a perch for birds. When humans leave, ecological pressure shifts. For centuries, Europe's forests were shaped by logging, agriculture, and hunting. Large predators were persecuted, moose were managed, lynx retreated to the continent's most remote corners. Here, that pressure evaporated almost overnight. Wolves returned first, cautious, exploratory, expanding from surrounding regions into an empty mosaic of forest and meadow. With no hunters to reduce their numbers, packs established territories quickly. Their presence reshaped everything beneath them. Moose expanded their range into abandoned agricultural fields, grazing on fresh growth where tractors once rolled. Red deer followed. With more prey and less competition, the Eurasian lynx began to disperse through the forests, reclaiming ground long denied to it. Predator and prey began to recalibrate old equations. The forest no longer echoed with engines or axes. Instead, it filled with hooves and howls. Food webs stretched outward, thickened, stabilized. Some species suffered from radiation exposure. Others thrived in the absence of human disturbance. The result was not simple, not purely triumphant, but undeniably dynamic. Chernobyl did not become a pristine Eden. it became something stranger, a vast, unintended experiment in rewilding. Roads faded beneath moss, villages dissolved into the canopy. The geometry of human settlement softened into organic lines. This is no longer a human landscape, it is a feral one. The exclusion zone stretches across the borderlands of northern Ukraine and southern Belarus, a vast mosaic of forest and floodplain carved by the slow persistence of water and time. At its heart lies the Pripyat River Basin, a winding artery threading through marshes, oxbow lakes, and peat-rich wetlands before ultimately joining the Dnieper. From above, it appears tranquil, a great green expanse stitched with silver ribbons of water. On the ground, it is a place of shifting textures. Pine forests dominate the higher sandy soils. Their trunks rise straight and pale, resin scenting the air in summer heat. Among them grow birch and alder, their leaves trembling in the slightest breeze. In the lowlands, wetlands spread outward in quiet defiance of gravity, reeds whispering over dark waters, sedges bending beneath dragonflies, mud marked with the tracks of passing animals. Mist gathers easily here. At dawn, a moose moves chest deep through a flooded meadow, its long legs stepping with deliberate grace. Each step sends ripples across the mirrored water. Steam rises from its flanks in the cool air. The animal lowers its head to feed on submerged plants, pulling stems that thrive in mineral-rich soil. Around it, the marsh breathes, frogs clicking, insects humming, unseen birds moving through the reeds. Farther south, along cracked rural roads, storks have claimed old power lines as nesting platforms. Their massive stick nests balance precariously atop leaning poles. Adults stand motionless against the sky, their beaks clattering in ritual greeting. Beneath them, grasses reclaim the ditches, and wildflowers bloom where tires once passed. In the distance, mist rolls over the concrete shell of the reactor dome, softening its brutal geometry. The structure rises above the forest canopy like a misplaced mountain, a reminder that this landscape was violently altered in a single night. Yet the contamination it released did not settle evenly. Radiation here is a mosaic. Prevailing winds in 1986 carried radioactive particles in unpredictable directions. Some areas, like the infamous Red Forest near the reactor, absorbed fallout so intense that pine trees turned a rusty orange and died within days. Even now, the soil in that area retains elevated levels of cesium-1, 3, 7 and strontium-9, 0, isotopes that persist for decades. Other regions, just kilometers away, received much lighter doses. Rainfall patterns created invisible boundaries. One meadow may be relatively mild, while a nearby forest remains heavily contaminated. For wildlife, there are no warning signs, no borders, only gradients of exposure woven into daily movement. A wolf crossing the forest may move from low-dose terrain into a hotspot without pause. A herd of moose may graze safely in one clearing and unknowingly enter another with higher residual radiation. And yet, life occupies nearly all of it. The geography of Chernobyl is not uniform devastation. It is complexity, wetlands rich in amphibians, pine forests echoing with woodpeckers, meadows heavy with ungulate tracks. The absence of cities, highways and agriculture has allowed habitats to connect seamlessly across hundreds of square kilometers. Density follows opportunity. Where wetlands widen, moose gather. Where young forest thickens, deer browse. Where prey multiplies, predators establish dominance. In this fractured yet expanding wilderness, geography does not repel life. It redistributes it. Winter tightens its grip over Chernobyl's forests. Snow settles into the cracks of abandoned roads and softens the jagged edges of concrete ruins. In this muffled silence, movement becomes visible. A line of tracks cuts across the white. Grey wolves, larger here, more numerous than in surrounding countryside, move through the forest in disciplined formation. Studies have shown that wolf populations within the exclusion zone are several times higher than in comparable areas beyond its borders, not because radiation favors them, but because people do not. A pack moves across a frozen clearing. Breath pours from their muzzles in steady clouds. Ears pivot, tails hold level. At the front, the alpha female pauses, nose lifted, reading the wind. Beneath the snow lies a complex archive of scent: red deer, fox, wild boar, the faint musk of moose. The wolves fan out. Their hunting strategy is ancient and precise. They test the herd, searching for weakness. A young deer breaks from formation, its hooves striking hardened snow. Instantly, the pack accelerates. Not chaotically, but in coordination. One wolf flanks left, another cuts right. They do not chase blindly, they steer, exhausting their prey in deep snow where long legs fail. In the distance, ravens gather. They know this rhythm. Beyond the hunt, territory defines survival. Along a road swallowed by pine saplings, a rusted bus tilts toward the earth. Its windows are gone, its frame skeletal. A wolf approaches, lifts its leg, and scent marks the corroded metal. The gesture is simple, the meaning absolute. This ground is claimed. Radioactive particles persist in the soil and leaf litter. Wolves living here are chronically exposed, ingesting contaminants through prey and water. Yet population numbers have not collapsed. The paradox is stark. Radiation imposes biological stress, DNA damage, possible reproductive costs, but the removal of human persecution has proven equally powerful. Outside the zone, wolves are often hunted, trapped, or displaced by expanding infrastructure. Inside, roads crumble, rifles are rare. The primary threat to a wolf is no longer man, but winter, hunger, or rival packs. With stable territories and abundant prey, wolves have begun to expand beyond the boundaries of the exclusion zone. Dispersing juveniles travel outward, crossing rivers and fields, carrying genes shaped by this strange refuge into broader European populations. Their howls roll through empty villages at dusk, threading through broken stairwells and silent courtyards. The sound is neither mournful nor triumphant. It is simply presence. In the hierarchy of the reborn ecosystem of Chernobyl, the wolf once again occupies the top, not mutated, not monstrous, but restored to ecological authority. In a land without hunters, the hunter thrives. Where tractors once traced a strict geometry on the ground, the meadows now ripple freely under the wind. The abandoned farmlands of Chernobyl have softened into open grasslands, and in these reclaimed clearings, the giants feed. At the edge of a former collective farm, a male red deer lowers its head into waist-high grass. Its coat glows coppery in the early light, with muscles shifting beneath the thick fur. Around him the females graze in a cautious rhythm, ears flicking at distant sounds. The air is heavy with the scent of damp earth and wildflowers rooted in soil once turned by human hands. The recovery has been dramatic. With hunting pressure removed and forests expanding into neglected fields, herbivore populations surged in the decades following the evacuation. Red deer multiplied. Elk, known in much of Europe as moose, pushed deeper into the wetlands of the Pripyat Basin, taking advantage of vegetation that thrives in nutrient-rich floodplains. In the marshes, a male moose moves through knee-deep water. Each step is deliberate, its long legs parting reeds with silent authority. It browses on willow shoots and aquatic plants, lips curling around tender growth. Dragonflies drift above its antlers. Behind it, the mud preserves the story of the night. Wolf tracks crossing deer trails, the choreography of predator and prey etched into the sediment. The season shapes their movements. In spring and summer, herds spread across open meadows and forest edges where fresh growth is abundant. In winter, they shift toward denser forests in search of shelter from wind and snow. Migration within the zone is fluid, without fences, without highways, without gunfire redirecting instinct. Then autumn arrives. Fog hangs low around a ruined farmhouse, the roof collapsed inward. In the yard, two male red deer face each other, breath steaming in the cold air. Their antlers are immense, branching like living crowns. A deep roar vibrates through the mist. Muscles tense. They surge forward. Antler strikes antler with a hollow crack that echoes against the broken walls. They twist and push, hooves tearing at the ground. This is not reckless violence, but ritualized combat, a test of strength and endurance. The victor will claim mating rights. The defeated will withdraw, antlers intact, pride bruised but life preserved. Nearby, hidden in tall, irradiated grass, brushing its spotted flank, a fawn lies motionless. Its survival depends on stillness. Even in a landscape marked by contamination, the oldest strategies endure. Along an abandoned railway, rails warped and half sunk into the earth. A moose carefully crosses the metal barrier. The line once carried workers and supplies. Now it carries only silence. Vegetation has surged in the absence of plows and pesticides. Young birches and poplars colonize the fields. Grasslands expand. Browsing pressure increases, and, in response, plant communities adapt. The system recalibrates. Chernobyl's herbivores are not symbols of purity. They are participants in a living experiment. Their numbers rise and fall with the severity of winter, predation, and the invisible variable of radiation exposure. And yet, across meadows and marshes, their presence is undeniable. The giants have returned to claim what regrew in our absence. There are predators that dominate through force, and there are predators that survive through absence. In the deepest reaches of Chernobyl's birch and pine forest, the Eurasian lynx moves like a rumor, rarely seen, seldom heard, and yet undeniably present. Across much of Europe, this feline is fragmented into isolated populations, constrained by highways, farmland, and centuries of persecution. Here, in the long silence left by evacuation, it has found space again. Snow falls softly through a pale grove of birches. Each trunk rises white against the dim winter light. Among them, something moves. A lynx steps forward, its thick winter coat patterned in muted gold and smoky grey. The black tufts of its ears twitch like antennae, catching every vibration. Its paws are disproportionately large, fur-lined, natural snowshoes that distribute weight across the fragile crust. It stops, perfectly still, as flakes settle on its back. Then it disappears. Not through speed, through stillness. The lynx is solitary. It does not travel in packs. It does not howl across valleys. Its territory can span hundreds of square kilometers, silently marked along forest trails and fallen logs. Within that domain, it hunts alone. Its preferred prey here is the roe deer, smaller and more agile than the red deer, but vulnerable to ambush. Unlike wolves, the lynx does not pursue over long distances. It stalks. Under the green of night vision, the forest transforms into a world of shadows and contours. A roe deer lowers its head to feed, its breath rising in soft clouds. 30 meters away, barely distinguishable from the undergrowth, the lynx crouches, muscles compress. The tail flicks once. Silence. Then an explosion of movement. 2 leaps, 3. A quick strike to the throat. The struggle is brief. Efficiency is survival. Radioactive isotopes persist in leaf litter and in the tissues of prey. The lynx, feeding on herbivores that graze on contaminated soil, accumulates exposure like any predator in this system. Yet its population here remains stable, even expanding. The reasons are multiple. Reduced human disturbance allows greater reproductive success. Forest cover has thickened, prey density has increased. Nature is not choosing radiation over humanity. It is responding to absence, recalculating risk. During spring, females raise litters in dens hidden beneath fallen trees or within abandoned structures reclaimed by moss. The cubs remain concealed for weeks, eyes opening to a world where silence means safety. At dawn, a lynx crosses a clearing where frost clings to rusted agricultural machinery. It does not look at the machinery. It looks beyond it. The forest swallows its silhouette again. Unlike the wolf, the lynx does not announce its return. Its recovery is measured not in howls, but in tracks. Round and padded impressions pressed into mud beside rivers and through snow-laden brush. It thrives not because it is stronger than its environment, but because it blends into it. In Chernobyl, survival does not always belong to the loudest. Invisibility is survival. If wolves shape the land through fear, wild boars reshape it through force. At the forest's edge, the ground appears churned by machinery. Patch after patch of soil lies overturned, roots exposed, moss peeled back in thick curls. But no plough passed here, no farmer returned. A female lowers her head and drives her snout into the earth. Wild boars are relentless diggers. Their muscular necks and reinforced snouts function like living shovels, capable of breaking frozen ground in winter and tearing compacted clay in summer. Beneath the leaf litter lies a hidden feast: roots, bulbs, tubers, beetle larvae, earthworms. The forest floor is not landscape, it is pantry. Piglets, striped with bands of brown and gold, dart across moss-covered clearings like scattered embers. They dash between ferns and fallen logs, squealing softly as they follow their mother's trail of disturbance. Within weeks of birth, they are already learning to dig. The boar's diet is unmistakably omnivorous. They consume plants, fungi, insects, carrion, bird eggs, even small vertebrates, when the opportunity arises. In autumn, acorns and other forest fruits become critical fuel, building fat reserves for winter. In spring, tender shoots and amphibians fill the gap. Their flexibility makes them resilient. It also makes them prolific. A single female can produce multiple piglets per litter, sometimes twice a year, under favorable conditions. In landscapes free of hunting pressure, populations expand rapidly. Chernobyl's abandoned fields and regenerating forests provide abundant forage. Wolves prey on them, but not enough to fully suppress their numbers. Their influence spreads outward. Rooting aerates the soil, redistributes nutrients, and exposes seeds to sunlight. In many ecosystems, such disturbance can increase plant diversity. However, here, an unusual tension arises. The soil of the exclusion zone contains radioactive isotopes deposited decades ago. By digging, bores disturb layers that may contain concentrated contamination. A snout pushes aside leaves near a faded radiation warning sign, half swallowed by ivy. The earth is turned. Dust briefly rises in the morning light. The act is instinctive, neither defiant nor cautious. Bores do not recognize symbols of danger. Scientists have detected elevated levels of cesium-137 inches, some bore tissues, especially in areas where contamination settled heavily. The isotope binds to organic material in the soil and in fungi, entering the food chain precisely through the rooting behavior that defines this species. And yet, bores persist. They move through abandoned kitchen gardens, foraging where potatoes once grew. They sleep beneath collapsed barns. They trot through empty village streets at dusk, hooves clicking against cracked pavement. At night, under infrared cameras, their silhouettes appear everywhere, compact, determined, tireless. Wild boars are not symbols of grace. They are engines of disturbance. By turning the soil, they reshape microhabitats, influence plant succession, and even redistribute radioactive particles over short distances. Life here is not static recovery, it is dynamic reorganization. In Chernobyl, even the soil refuses to remain undisturbed. Not all of Chernobyl's fauna returned on their own. In the 1990s, conservationists introduced a species that had once vanished from the wild, the Przewalski's horse. Stocky, dun-colored, with upright manes and powerful necks, these horses are the last truly wild equid species on Earth. Unlike feral horses descended from domestic stock, Przewalski's horses were never fully domesticated. They arrived here as an experiment. The exclusion zone, emptied of intensive agriculture and human settlement, offered vast grasslands and minimal disturbance. Radiation remained a concern, but so did the global decline of large herbivores. The question was pragmatic. Could this unusual refuge sustain a species lost from its ancestral steppes? The answer unfolded in hoofbeats. At dawn, a herd moves across an open meadow, their silhouettes passing before the distant mass of the reactor containment structure. The contrast is stark living muscle against engineered ruin. Foals trot awkwardly beside their mothers, legs too long for their small bodies. They stumble, recover, and burst into playful spurts of speed through tall grass brushing their flanks. Przewalski's horses live in structured social groups. A dominant stallion leads a harem of mares and their offspring. He positions himself at the rear when the herd moves, scanning for threats. Younger males form bachelor groups, testing strength and patience before attempting to claim mares of their own. By late spring, tension sharpens. Two stallions circle each other in a clearing. They lower their heads, ears pinned back, muscles coil beneath thick hides. with a sudden lunge. They collide, teeth bared, forelegs striking, necks crashing with blunt force. Dust rises. The confrontation is fierce but measured. These battles establish hierarchy, not annihilation. The victor drives his rival off in a brief, explosive chase. The herd regathers, rhythm restored. Over the decades, the population within the exclusion zone has grown steadily. Foals survive into adulthood, bands split and reform. The horses roam freely across grasslands once ploughed and sown by human hands. They graze constantly, trimming grasses and maintaining open habitats. In doing so, they influence plant composition, prevent forest encroachment in certain areas, and create grazing lawns that benefit smaller herbivores and insects. Their presence reshapes the landscape in subtle but significant ways. Radiation exposure remains part of their environment, invisibly woven into the soil and vegetation. And yet, like wolves and deer, they persist not because contamination is harmless, but because the absence of fences, vehicles, and culling has altered the balance. The herd breaks into a gallop, hooves thundering over ground that once echoed with evacuation sirens. Manes lift in the wind. For a moment, the reactor dome is just another feature on the horizon. Chernobyl was never meant to become a sanctuary. But in the void left by disaster, rewilding took root, not as a pristine restoration of the past, but as an improvised future. Here, extinction found opportunity, and the steppe began to run again. Above the forests and the fractured rooftops of Chernobyl, the sky has not emptied, it has filled. In the chimney of an abandoned country house, a white stork stands atop a nest the size of a cartwheel. Branches, wire, scraps of fabric woven into a fortress precariously balanced on bricks softened by time. The stork's red beak clatters softly as its mate glides in from the wetlands with broad and deliberate wings. Each spring they return from migratory routes that carry them across the Mediterranean and into sub-Saharan Africa, navigating continents to reclaim this silent village. They do not see ruins, they see elevation and safety. Higher still, an eagle circles above the cooling towers of the Chernobyl nuclear power plant. Thermals rising from sun-warmed concrete lift it effortlessly. From this height, the forest appears endless, interrupted only by pale scars of road and river. The eagle tilts a wing, searching for movement, a hare emerging from cover, a duck taking flight from the marsh water. Predators adapt to opportunity. With fewer humans and more prey, raptors have expanded their presence within the exclusion zone. The absence of disturbance at nesting sites, no logging crews, no hikers, no urban expansion, has created rare pockets of uninterrupted breeding habitat. Inside a crumbling apartment block in Pripyat, a barn owl rests in what was once a living room. The wallpaper peels behind it. Dust floats in beams of light that cut through broken glass. At dusk, it will glide silently through stairwells and courtyards, hunting rodents that now dominate the understory. Concrete has become cliff. Corridors have become canyon. Deeper in the forest, woodpeckers hammer at dead pine trunks, many of them killed by the intense radioactive fallout of 1986. Their rhythmic drumming echoes through stands of skeletal trees. Dead wood, often removed in managed forests, remains here in abundance. It supports insects. The insects support birds. The chain persists. Yet radiation has left measurable marks. Some long-term studies have documented higher rates of cataracts, reduced brain size in certain species, and occasional abnormalities in plumage, patches of partial albinism, or deformities in feathers. particularly in areas of higher contamination. Exposure to ionizing radiation can damage cells, increase oxidative stress, and affect development. But the story is complex. Not all species respond equally. Not all areas are equally contaminated. Migration adds another layer. Many birds spend only part of the year within the zone, diluting exposure across broader geographic ranges. Others are year-round residents, experiencing chronic low-dose radiation across generations. The sky does not convey these subtleties. At sunset, storks settle into nests atop collapsed chimneys. Eagles disappear beyond the tree line. Owls take flight, wings slicing silently through empty streets. From above, Chernobyl is less a scar than a mosaic: forest, marsh, ruin, regrowth. The silence humans left behind has become acoustic space for wings. And in that vast and unstable sky, life continues to turn. Beneath the hooves of moose and the padded silence of wolves, another world pulses unseen. In the leaf litter beneath a fallen pine, a vole slips between exposed roots, disappearing into a tunnel no wider than a thumb. Its heart beats at a frantic rhythm. Its life can be measured in months. But within that short window, it will reshape the ecosystem. Rodents are the silent architects of Chernobyl's recovery. With farmland abandoned and predator persecution reduced, small mammal populations surged in the years following the evacuation. Abandoned fields became ideal habitat for mice and voles. Grasses thickened. Seeds multiplied. Burrows spread like underground cities beneath meadows and forest edges. Their reproductive strategy is simple and ruthless: speed. A female vole can produce multiple litters in a single breeding season. The young mature rapidly, reproducing within weeks. Under favorable conditions, populations can explode, waves of fur and teeth moving through the vegetation. A red fox stands motionless in a snow-covered clearing. Its ears rotate, triangulating faint movement beneath the hardened surface. Suddenly it leaps, a precise vertical pounce. Snow bursts apart. The fox emerges with a mouse clenched in its jaws. Energy transferred, life exchanged. Small mammals form the base of countless food chains here. Owls hunt them in abandoned stairwells. Lynx cubs learn to stalk them. Snakes follow their trails through summer grass. Their abundance sustains predators large and small. Yet in Chernobyl, rodents carry another meaning. Due to their short life cycles and rapid reproduction, they are ideal subjects for studying the biological effects of radiation. Generations turn over quickly, allowing scientists to observe evolutionary responses over decades. Radiation can damage DNA, increasing mutation rates. In areas of high exposure, researchers have documented elevated genetic changes in some rodent populations, alterations in chromosomes, shifts in gene expression, signs of oxidative stress. But mutation does not mean transformation into something monstrous or enhanced. Mutation is random. Most genetic changes are neutral or harmful. A few may confer slight advantages for coping with stress. Natural selection acts quietly, filtering what persists from what fails. Individuals better able to repair cellular damage or tolerate oxidative stress may leave more offspring. Over time, populations adjust, not into super animals, but into organisms shaped by pressure. A vole pauses at the mouth of its burrow, whiskers trembling. Above it, snow drifts softly through skeletal branches. The forest appears still, but beneath the surface, tunnels weave into intricate networks. Seeds are stored, soil is aerated, nutrients circulate. In the absence of humans, small mammals filled every available niche. Radiation remains part of their environment, an invisible variable layered over predation, climate, and competition. They do not glow. They do not defy physics. They adapt, reproduce, and die in cycles as ancient as mammals themselves. In Chernobyl, survival belongs not only to the powerful, but also to the prolific. If large mammals are the visible symbols of Chernobyl's return to the wild, insects are its hidden machinery. In a meadow reclaimed from agriculture, wildflowers sway in dense clusters, loose strife, clover, thistle. A bee lands, its legs heavy with pollen. Another follows. The air vibrates with a low, constant industry. Pollination here is no longer regulated by pesticides or disrupted by tractors. It unfolds solely according to season and sunlight. Butterflies drift over the grasses, their wings delicate mosaics of color. Yet, in this landscape, even beauty carries a scientific question. In the years following the accident, researchers documented elevated rates of wing deformities and changes in pigmentation in certain butterfly populations, particularly in highly contaminated areas. Radiation, especially during early stages of development, can interfere with cell division and pattern formation. A slight asymmetry, a malformed antenna, subtle signals of environmental stress. But, as with rodents, the picture is not uniform. Butterfly abundance varies depending on habitat quality as much as on radiation levels. In areas where vegetation has thrived undisturbed, populations remain robust. Exposure interacts with food availability, temperature, and predation in complex ways. Life here is not a simple story of damage or triumph. It is layered. On the forest floor, decomposition never stops. Fallen leaves soften into dark humus under the work of beetles, millipedes, fungi, and bacteria. Termites chew through dead wood. Ant colonies excavate beneath tree roots. Each organism participates in breaking down what once stood tall, returning nutrients to the soil that feeds the next generation of growth. Without decomposers, forests would choke on their own remains. In Chernobyl's red forest, where radiation once killed swathes of pine, fallen trunks remained for years largely intact. Decomposition slowed in the most contaminated zones. Microbial communities sensitive to radiation shifted. Fungal networks adapted or diminished. Even now, scientists study how these microscopic changes ripple upward through the ecosystem. At the edge of an abandoned apartment block, a spider web stretches between two broken window frames. Morning dew gathers along its strands, turning silk into a necklace of glass. The spider waits at the center, motionless, sensing vibrations invisible to the eye. The building once housed families, now it houses invertebrates. Insects pollinate meadows, feed birds, recycle forests, and regulate plant communities. They are the connective tissue of this reborn wild nature. Remove them, and the system fractures. The wolf hunts the deer grazes the grass, but the grass blooms because bees visit it. The soil nourishes roots because beetles and fungi dismantle what has fallen. Chernobyl is not defined by the survival of a single species. It is defined by interaction, layers of life stacked upon one another, from microorganisms to megafauna. Each level supports the next. Each depends on what lies beneath. In the quiet hum of wings and the patient weaving of silk, the deeper architecture of this ecosystem is revealed. life here is not simply returning. It is rebuilding from the smallest threads upward. A few kilometers west of Reactor 4 lies one of the most contaminated landscapes on Earth, the Red Forest. In the days following the 1986 explosion at the Chernobyl nuclear power plant, a plume of radioactive particles drifted over this mass of pine trees. The dose was acute. The needles turned a deep rust red within days, as if autumn had arrived in a single violent breath. Soon after, the trees died standing. The name remained. Today, the original pines are mostly gone, pushed over by bulldozers and buried in trenches during early cleanup efforts. But contamination persists in the soil. Cesium-137 and other isotopes bind to organic material, settling into leaf litter and sediment. Radiation levels here remain significantly higher than in much of the surrounding zone. The forest feels different. Trunks rise at strange angles, some blackened by past fires, others skeletal and pale. Underfoot, the ground is soft with moss, thick green carpet spreading over altered soil. Where the first generation of trees fell, succession began. Birch and aspen colonized open spaces, their lighter canopies altering how sunlight filters downward. Regrowth here is a mosaic. In areas of extreme contamination, plant diversity remains lower. Some studies suggest that radiation affected seed viability and slowed decomposition in the early years, allowing fallen wood to accumulate. In other sectors, vegetation has recovered vigorously, filling gaps with shrubs and pioneer species. Fungi thrive in this shadowed world. Mycelial networks thread through the soil, breaking down organic remains and transporting nutrients between roots. Certain fungi can accumulate radioactive elements, drawing cesium into their tissues. Wild boars that consume these fungi often show elevated contamination levels, a reminder that energy and isotopes move through food webs. The red forest is not silent, but it is muted. Woodpeckers drum against hollow trunks. Insects buzz in the summer heat. A fox slips between charred stems, its fur brushing bark that once absorbed lethal radioactive fallout. Life persists, but it does so atop a layered past. Fire is the persistent risk. Dead wood accumulated in the years following the accident, creating dense fuel loads. During dry summers, lightning or human intrusion can ignite wildfires. When flames pass through contaminated zones, radioactive particles trapped in vegetation and soil can become airborne again, carried by smoke beyond the forest's boundaries. Each fire reopens a chapter once thought closed. Charred trunks stand as both relic and warning. And even here, moss reclaims the ground. Ferns unfurl among blackened roots. Saplings push upward through ash. Ecological processes continue, slower in some places, altered in others, but not extinguished. The red forest is not a wasteland frozen in catastrophe. It is a living system under stress, shaped by an event that rewrote its chemistry. Radiation remains here an invisible architect, influencing growth, decay, and risk. But it is not the only force at work. Wind, water, microbes, and time have joined the story. And in their patient and persistent labor, even the most contaminated soil is reintegrated into the cycles of the forest. Winter arrives silently in the exclusion zone. Snow does something curious here. It does not erase contamination, but it hides it. Radioactive particles attached to soil and leaf litter become sealed beneath a white layer. Dust carried by the wind, one of the main pathways for redistributing cesium and strontium, is dampened. The landscape grows quiet. For a few months, the air carries fewer invisible travelers. Radiation does not disappear, it simply waits. A frozen river cuts through the forest like a pale scar. The ice seals the surface, muffling the current below. Along its banks, tracks accumulate: deer, boar, fox. The snow is a recording device. Every step leaves a confession. For wolves, winter is an advantage. In the forests around the Chernobyl nuclear power plant, wolf populations have grown in the absence of human hunting pressure. Deep snow slows moose and deer, increasing the energy cost of escape. A coordinated pack can run an animal to exhaustion over hardened drifts. The white ground sharpens contrast. Movement gives itself away. Predation becomes more efficient. But winter is not generous. Food scarcity pressures all herbivores. Browsing, twigs, bark, dormant buds replace the abundance of summer. Body fat becomes currency. Every miscalculation brings consequences. Moose migrate in response. Some individuals move toward less contaminated areas or seek ground where forage remains accessible under thinner snow cover. Migration here is not only about avoiding radiation, it is about calories. Large mammals balance exposure and survival in a calculation written in muscle and instinct. Radiation behaves differently in winter. Cold temperatures slow microbial decomposition in the soil. Organic matter breaks down more slowly, retaining isotopes in place. Meltwater, when it comes, will redistribute part of this load, carrying contaminants to low wetlands. But during freezing, mobility is reduced. The snow layer acts as both insulator and temporary archive. The reactor dome remains under frost. Steel and concrete gleam under the crystalline air. The new safe confinement structure arches over Reactor 4, like a colossal shield, its surface rimmed with ice. It appears inert, almost peaceful. Appearances deceive. Inside the shelter, fuel-containing materials remain, unstable in form but contained by engineering. Outside, ecosystems continue their experiment of adaptation. The contrast is stark. Human technology holding catastrophe in suspension, biological systems reorganizing around it. Winter compresses sound. Branches crack under weight. Ravens call sharply against a muted sky. Breath hangs in visible plumes before dissolving. The forest feels suspended, not dead, not flourishing, but paused. Snow softens the geometry of the ruins. Concrete blocks blur into rounded mounds. Moss beneath the frost waits for thaw. Seeds lie dormant in frozen soil, indifferent to contamination, sensitive only to temperature and light. When spring arrives, meltwater will move what winter has held in place. Dust will rise again. Wolves will disperse toward denning territories. Moose will seek new growth. But in winter, Chernobyl feels almost pristine. A white silence covers the chemistry below. Nature does not clean the past, it covers it in layers. Snow is not redemption. It is a temporary truce between wind, soil, and isotope, a season in which even the most contaminated ground can appear untouched nature. And that resemblance is its own form of unease. Winter loosens its grip in increments. Snow collapses into rivulets. Ice fractures along the spine of the river. The white silence dissolves, and something electric moves through the undergrowth. Spring in the exclusion zone is not subtle. Birdsong returns first, timid at dawn, then insistent. Warblers stitch sound through young leaves. Woodpeckers resume percussion. Above, storks circle over wetlands swollen by thaw. The air feels crowded with wings. The contrast is striking. Where frost once sealed the ground, Green shoots now rise upward, moss brightens, birch leaves unfold into translucent sheets. Radiation remains interwoven in the chemistry of the soil, but it does not stop photosynthesis. Sunlight strikes chlorophyll, sugars flow, cells divide, life insists. In clearings, fawns are born. Roe deer choose dense cover for their young. A newborn lies motionless in tall grass, its spotted coat mimicking fractured light. Its survival strategy is stillness. Predators react to movement. Nearby, the mother grazes, ears turning like satellite dishes. Within hours, the fawn can stand. Within weeks, it can outrun danger. Wolves adjust accordingly. Spring abundance changes the hunt. Vulnerable juveniles are easier prey, but overall prey density increases. Predators, too, now have dens. Pups wait in sheltered hollows while adults move outward. Energy flows rapidly through the food web, sunlight to plant, plant to herbivore, herbivore to carnivore. Insects arrive in waves. Wetlands expand as thaw floods low ground, creating temporary nutrient-rich pools. Mosquito larvae ripple beneath the surface. Dragonflies emerge, breaking from their aquatic skins and rising into the air on trembling wings. Beetles, bees, and tiny midges saturate the undergrowth. The forest hums. These insects are more than background noise. They pollinate flowers. They feed birds. They accelerate decomposition. Some accumulate radioactive isotopes within their bodies, transferring trace elements up the chain. Energy transfer is indifferent to contamination. It follows gradients of availability. Spring amplifies every pathway. The expansion of wetlands transforms the terrain. What was forest floor becomes a shallow lake. Amphibians converge in choruses, frogs calling in rhythmic pulses that travel across open water. Eggs cling to submerged grasses. Tadpoles are born into a world temporarily abundant and precarious. As summer approaches, many of these pools will evaporate, compressing life into ever narrower margins. Light lingers longer each evening. The reactor structures, distant and angular, appear less dominant beneath the fresh canopy. Leaves soften their silhouette. Vines climb the concrete. The geometry of industry blurs behind organic forms. Not erased, simply outnumbered. Spring is a recalibration. Metabolic rates increase. Reproductive clocks activate. Migration routes pulse with return. Even in one of the most contaminated landscapes on Earth, the seasonal script unfolds with remarkable fidelity. Hope here is not naive. It is biological. Given temperature, water, and light, cells will replicate. Populations will recover where conditions allow. Some species will struggle, others will flourish. Ecosystems are not moral agents. They are dynamic systems that respond to constraints. The exclusion zone in spring feels almost exuberant. Birdsong overlays memory. Fawns test their legs in meadows seeded by past catastrophe. Dragonflies patrol over waters that did not exist weeks before. Radiation shapes the background, but sunlight writes the foreground. And for at least one season, the balance tilts toward growth. Dawn. Mist hangs low over the meadow, thin as breath. A deer lifts its head. In the distance, a figure moves between birch trunks, then another, then three more. The wolves do not hurry. They spread out, silent, grey against grey. Snow still clings in shaded hollows, hardened and brittle. The first run is explosive. Powder snow bursts. Hooves thunder against frozen ground. The herd fractures. A young male veers left, a mistake. Wolves do not chase the fastest. They choose the one that falters. The pack flows behind him like smoke given muscle. Distance closes in increments. Breath becomes vapor. The forest blurs. Stillness. A lynx crouches beneath fallen timber. Tufted ears, unblinking eyes, muscles coil beneath spotted fur. It has been here an hour, perhaps more. Patience is its currency. A hare stirs into view. The lynx does not move. The wind shifts. Leaves tremble. The hare lowers its head to feed. 1 step. 2. The strike is vertical lightning. Midday sun. Tall grass ripples. A fox stands motionless, listening, head tilted, ears triangulating faint movement beneath the ground. A vole digs unseen. The fox adjusts its posture a fraction, then leap. For a suspended second, it hangs above the meadow, legs tucked. It dives nose first into the earth, disappearing in an explosion of seed heads and dust. It rises with something small and writhing in its jaws. Quick bite, efficient, no excess. Cut, sky. A hawk circles on thermal currents, rising from warming wetlands. Wings fixed, tail feathers fanned. Below, reeds sway, and frogs call from the margins of expanding pools. The hawk's eye locks. Gravity does the rest. It folds its wings and becomes a falling blade. The air screams past its feathers. At the last instant, talons extend. Water explodes upward. The hawk rises again into the sky, clutching a silver movement that flashes once under sunlight before going still. Wide shot. The meadow breathes again. Nothing here is theatrical. There is no music. There is no judgment. Predators eat because metabolism demands it. Prey flee because neurons fire in ancient circuits shaped by survival. Every movement is calibrated by evolution. Small adjustments refined over thousands of generations. The wolves finish their run beyond the tree line. The lynx drags its catch into cover. The fox trots along a hedgerow, tail low and satisfied. The hawk perches on a skeletal branch, tearing with efficient precision. In the exclusion zone, human absence has amplified these sequences. Roads do not interrupt pursuit. Gunfire does not scatter herds. The choreography feels uninterrupted. Not pristine, but uninterrupted. Predator and prey, movement and stillness, hunger and escape, a system in constant negotiation. Life here is not gentle, it is balanced on the chase. Radiation is not a toxin in the conventional sense, it is energy. When ionizing radiation passes through living tissue, it deposits that energy into atoms and molecules. The most consequential target is DNA, the long-coiled molecule that stores genetic instructions. Ionizing radiation can break chemical bonds directly, splitting one or both strands of the DNA helix. A double-strand break is particularly severe. It is the molecular equivalent of cutting a ladder in half. Cells are not defenseless. They possess repair systems, molecular toolkits that detect damage and rejoin DNA. These systems evolved long before nuclear reactors. Natural background radiation, ultraviolet light, and reactive chemicals generated during metabolism have always threatened genetic integrity. Life has been improvising repairs for billions of years. Indirect damage is often more common than direct hits. Radiation interacting with water, which makes up most of a cell, can split molecules into highly reactive fragments called free radicals. These unstable molecules trigger oxidative stress, a state in which reactive oxygen species accumulate faster than they can be neutralized. Oxidative stress can damage DNA, proteins, and cell membranes, subtly altering function even when the DNA backbone remains intact. In the Chernobyl exclusion zone, organisms experience chronic low to moderate exposure rather than the acute doses received in 1986. Chronic exposure changes the biological question. Instead of what dies immediately, the focus becomes what changes across generations. Researchers have compared populations within the zone with those in uncontaminated areas. The results are complex. Some studies report elevated mutation rates in certain birds and small mammals living in highly contaminated hotspots. Others find minimal observable differences in survival or reproduction when averaged across broader areas. Methodology matters. Species differ in lifespan, mobility, and exposure pathways. Rodents living in soil encounter contamination differently than migratory birds. Adaptation is a working hypothesis, not a slogan. If a population persists across generations under radiation stress, natural selection may favor individuals with more efficient DNA repair, stronger antioxidant defenses, or life history strategies that compensate for damage. There is evidence in some species, such as certain birds, of improved antioxidant capacity in contaminated regions, but adaptation does not imply immunity. It suggests statistical filtering. Individuals less able to cope with the situation are less likely to reproduce. The absence of humans complicates interpretation. Within the zone, hunting pressure is reduced. Habitat fragmentation is minimal. These factors alone can increase wildlife abundance. So when animal populations appear robust, separating effect of radiation from effect of human absence becomes difficult. A thriving wolf pack does not automatically indicate harmless radiation. It may reflect ecological release from human pressure. Laboratory experiments provide clarity but remove context. Controlled exposures reveal dose-response relationships at the cellular level. Higher doses correlate with higher rates of chromosomal aberrations and oxidative damage. However, translating laboratory findings to free-living ecosystems requires caution. Real organisms experience fluctuating exposures, variable diets, seasonal stresses, and complex social structures. Radiation is neither a mythical curse nor a trivial background. It is a measurable physical phenomenon with probabilistic biological consequences. Effects increase with dose and duration. Some individuals and species tolerate it better than others. Populations can persist even as subtle cellular damage accumulates. Chernobyl has become an involuntary field laboratory. Not pristine, not benign, but instructive. Here, biology is negotiating with physics in real time, repairing, compensating, adapting when possible. The story is not one of invulnerability, nor of inevitable collapse. It is a story of gradients, dose, time, repair, selection. Life does not ignore radiation. It responds to it. Take radiation out of the equation for a moment. Remove reactors, isotopes, containment structures. What remains is something ecologically radical: absence. Without agriculture, across much of Europe, land is divided into fields: wheat, rapeseed, corn, geometry imposed on the soil, trimmed hedgerows, pesticides applied, harvest cycles synchronized with market demand. In the exclusion zone, plows stopped in 1986. Farmland reverted to grassland. Orchards collapsed and transformed into scrub. Succession, the gradual replacement of plant communities over time, resumed uninterrupted, without highways. Elsewhere, Europe is interwoven with asphalt. Roads fragment habitat, dividing animal territories into smaller, riskier pieces. Collisions kill millions of animals each year. Noise and light spill into surrounding ecosystems. In the zone, The expansion of major roads ceased. Pavement cracked. Birch roots lifted the concrete. Corridors reconnected. Without hunting pressure. In densely populated regions of Europe, wildlife management includes regulated culls, seasonal hunts, predator control. Human predation is selective and technologically amplified. In the exclusion zone, that pressure dropped drastically. Wolves, wild boar, moose, species often suppressed elsewhere, expanded into vacated niches. Predator-prey dynamics recalibrated without rifles in the system. Less noise. Anthropogenic noise, traffic, machinery, industry reshapes behavior. Birds alter the frequency of their songs to compete with engines. Mammals shift activity to nighttime hours to avoid disturbance. Chronic noise elevates stress hormones. In Chernobyl, background sound levels dropped dramatically. Wind in the trees replaced engines. Behavioral patterns relaxed toward more natural circadian rhythms. This absence acts as a force. Ecology often focuses on presence, new species, pollutants, climate shifts. But subtraction can be just as powerful. Remove a dominant species, in this case humans, and trophic cascades unfold. A trophic cascade occurs when changes at the top of the food chain propagate downward, altering vegetation, soil, and even hydrology. Compare this with densely inhabited regions of Western Europe. There, landscapes are intensively managed mosaics, fragments of forest interspersed with villages. Agricultural runoff alters waterways. Domestic livestock compete with wild herbivores. Even protected parks exist within a matrix of human infrastructure. Biodiversity persists, but within constraints. In the exclusion zone, constraints are different. Radiation imposes chemical stress, but land use intensity dropped nearly to zero. For many species, the benefits of reduced human disturbance appear to outweigh chronic radiation exposure across much of the territory. Population censuses have documented high densities of large mammals compared to surrounding non-contaminated areas with active agriculture and settlement. This does not romanticize abandonment. Communities were displaced, economies were disrupted, cultural landscapes were frozen in time. Ecological gain was born from human loss. And yet, scientifically, the zone functions as a large-scale rewilding experiment, unplanned, imperfect, but revealing. It highlights how deeply modern European ecosystems are shaped not only by climate, but by continuous human presence. Ploughed fields, cleared forests, dammed rivers, roads laid. Remove those forces, and biological systems expand into the space left behind. Chernobyl demonstrates something uncomfortable and instructive. For many species, the most transformative environmental variable is not radiation, it is us. A wolf crosses a frost-covered field. Behind him lies the exclusion zone, forests interwoven with memory and isotopes. Ahead lies Belarus. The wolf does not hesitate at the political border. There is no signal in its perceptual world that says state line. There is only terrain, scent, hunger, and opportunity. Young wolves disperse. When they reach 2 or 3 years of age, many leave their natal packs. This dispersal reduces inbreeding and spreads genes across landscapes. In the forests surrounding the Chernobyl nuclear power plant, researchers have fitted some wolves with GPS collars. The data reveals something striking. Individuals travel far beyond the contaminated core, sometimes hundreds of kilometers. The zone is not an ecological island. It is connected. Genetic mixing follows movement. When dispersing wolves mate outside the zone, they introduce alleles, versions of genes shaped by whatever selective pressures existed within. If certain traits related to stress tolerance or DNA repair have been favored, those genes do not remain confined. They diffuse into broader regional populations. This is hypothesis, not mythology. Genetic studies comparing wolves inside and outside the zone show no clear evidence of severe inbreeding or isolation. On the contrary, gene flow appears continuous. Movement prevents the zone from becoming a closed evolutionary experiment. It is porous. Ecological corridors make this possible. Corridors are stretches of habitat that allow animals to move safely between larger habitat blocks. In Eastern Europe, forests extend across borders between Ukraine and Belarus. Agricultural intensity varies, but in many regions forest continuity remains sufficient for wide-ranging carnivores. For a wolf, a corridor is not a concept. It is cover. Movement carries risk. Outside the zone, hunting resumes, roads reappear, human density increases. A wolf, leaving the relative silence of abandoned villages, enters a landscape of villages that breathe, cultivate, and drive. Mortality risk rises, and yet dispersal persists because genetic diversity is survival insurance. Borders are human geometry. Animals respond to ecological gradients, forest density, prey abundance, disturbance levels, not to political maps. A snow-covered field between Ukraine and Belarus is simply a transitional strip of habitat. The wolf crosses because scent trails continue, because prey migrate, because instinct says move. Migration also applies to other species. Moose, deer, and wild boar roam across borders. Birds ignore them entirely, navigating by stars and magnetic cues. Even smaller mammals shift outward across successive generations, expanding their ranges when conditions allow. Radiation also migrates in subtle ways. Isotopes carried in fur, flesh, and bone move with organisms. Predators feeding outside the zone may incorporate trace contaminants into broader food webs. Levels are typically low, diluted by distance and diet, but the principle remains. Systems are connected. The wolf reaches the tree line. It pauses only long enough to smell the wind. The exclusion zone falls behind, not as a prison, not as a sanctuary, but as one habitat among many. Movement dissolves edges. Genes travel. Ecosystems overlap. Chernobyl is often imagined as sealed. It is not. It breathes outward, through rivers, through air currents, through dispersing animals whose paws briefly imprint the snow before carrying the story elsewhere. From the air, the exclusion zone appears almost indistinguishable from a national park. The forest canopy stretches unbroken to the horizon. Wetlands glisten in fractured light. Rivers curve without concrete embankments. In spring and summer, the green is dense enough to swallow entire villages. It was never intended to be a reserve. And yet, in the decades since the explosion at the Chernobyl nuclear power plant, the 30-kilometer zone has functioned, in practice, as one of Europe's largest involuntary wildlife refuges. Compare it with designated parks across Europe. National parks are often islands, protected cores surrounded by farmland, highways, and towns. They are carefully managed. Populations are monitored. In some cases, predators are controlled. Tourism shapes infrastructure. Protection exists, but it coexists with constant human negotiation. Chernobyl is different. There are no hotels at its center, no seasonal hunting permits, no picnic clearings. Human access is tightly restricted. Agriculture ceased. Logging largely stopped. Settlements were left empty. Large mammals, wolves, moose, wild boar, expanded rapidly after the evacuation. Przewalski's horses, introduced in the 1990s, established free-ranging herds. Bird diversity censuses record hundreds of species. In terms of sheer biomass of certain animals, the zone rivals or exceeds surrounding inhabited regions. This leads to an uncomfortable scientific debate. Is chronic radiation exposure, at the levels present across much of the zone, less ecologically disruptive than intensive human land use? Some researchers argue yes, cautiously. They point to population counts, camera traps filled with movement, the absence of tractors, chainsaws, and rifles. They suggest that, although radiation imposes measurable biological stress, the removal of humans reduces mortality and habitat fragmentation so drastically that wildlife thrives overall. Other scientists disagree. They highlight localized hotspots where contamination remains high. They document increased mutation rates in certain species. They warn against equating visible abundance with long-term health. A forest full of animals does not automatically mean those animals are unaffected at the cellular level. Both perspectives contain truth. Radiation is harmful in proportion to dose and duration. That principle does not dissolve in a poetic frame. At the same time, modern European landscapes are deeply shaped by human extraction and infrastructure. Habitat loss is one of the primary drivers of biodiversity decline globally. Chernobyl exposes a paradox. Remove humans, and ecosystems recover in visible and dramatic ways, even in a chemically altered environment. Keep humans present, and ecosystems fragment, even in chemically clean environments. This does not suggest that nuclear disaster is a conservation strategy. The social cost was immense. Communities were displaced. Cultural histories were severed. But the zone stands as a case study of ecological release, an accidental reserve. It forces a comparison few are comfortable making, between invisible radiation and visible roads, between molecular damage and mechanical disturbance. Which exerts greater pressure? The answer depends on scale, species, and time horizon. Chernobyl does not resolve the debate. It complicates it. And in that complication lies its value, a landscape that asks, without accusation, what kind of presence we wish to have on Earth. The explosion at the Chernobyl nuclear power plant was not an abstract environmental event. It was a technological failure with human consequences measured in evacuation orders, lost homes, disrupted livelihoods, and decades of medical monitoring. Entire communities were uprooted. Cultural landscapes, schools, farms, villages were sealed behind checkpoints. The cost was social as much as biological. Radiation does not disappear with headlines. Certain isotopes decay over years. Others persist for decades. Contaminated soils continue to circulate through ecosystems. Forest fires can remobilize particles that settled long ago. Monitoring remains necessary. The story continues. And yet, alongside contamination, forests regrew, wetlands expanded, wolves dispersed. In the absence of plows and highways, ecological processes resumed with unexpected vigor. This is the paradox. A landscape rendered unsafe for permanent human settlement became, involuntarily, a refuge for wildlife. The same event that fractured human continuity reduced human pressure. Damage and recovery unfolded in parallel. It would be simplistic to call this redemption. Nuclear disasters are not conservation tools. They carry unpredictable risks, long temporal shadows, and profound human suffering. The ecological resilience of the exclusion zone does not erase its origin. What Chernobyl reveals is more nuanced. Human influence is powerful enough to devastate and to release at once, remove it abruptly, and ecosystems reorganize. maintain it carelessly, and they fragment. In Chernobyl, humanity's greatest technological failure became nature's involuntary sanctuary. But this is not a model to follow. It is a reminder that when we disappear, life continues. The question is whether we will learn to live without forcing it to do so. But what do you think?